Hey there, welcome back. I'm here in beautiful Mount Forest, Ontario, just outside of it actually, and I'm on this, you can see around me, this very interesting property, and I'm here with Tom Davis. Tom Davis is an environmental engineer, Fanshawe faculty, and our resident sustainability guru, really. And Tom, thanks for talking to us.
Thank you, Matt. Thanks for making the drive out from London on a beautiful day.
It's a gorgeous day. And I want to know what you've got going on here, because this is a really neat property and you've done some things to make this place sustainable.
Thanks, Matt. I've tried. This is a work of a lifetime, but I guess maybe let's get oriented a little bit. That, as you had indicated, we're just outside of Mount Forest, Ontario, and a half a mile that direction is the nearest roadway. So there's a private roadway that leads back here, and just over my shoulder you can see the power supply. This has only ever been firstly developed by myself. Before this it was bare land. So when I came out here, I didn't want to have a whole row of hydro poles going out to the roadway. And 15 years ago, this is the state of the art as far as off-the-grid technology. So I have a photovoltaic array, a PV array, as you can see here in the foreground, and in the background a small wind turbine. And the combination of the two between the sunlight, and if the sun isn't shining, the wind's usually blowing up here. We're at a very high elevation, so we have year-round power.
So you can keep yourself going without any intake from the electricity grid.
That's correct. There's never been a wire to this house, and if I have my way, there never will be.
Now I understand you've also made some other innovations, and you've incorporated some other design elements to this place. Do you think you could show us some of them?
Absolutely. So it's all about catching energy, and these are just two ways of catching energy. Obviously the wind and the sunshine, but we also use the prevailing breezes as a form of air conditioning, and we also use the lower sunlight in the wintertime as a form of central heating. And I can show you around the place and give you an idea of how some of those things work.
That'd be fantastic. Let's go take a look.
Okay.
Well, we're here out front of the house now, and Tom, I've got to ask you. I mean, it's a very neat solar array, or the photovoltaic cells you've got there, but that can't possibly generate enough energy to heat your whole house, for example.
Right. The electricity is probably the worst thing you want to use for heating, and what we like to do, especially when we're relying on off-the-grid technologies, is to take advantage of some of the other energy sources that are available to us. As you can see with the house, its orientation is basically south with a little bit of a southeasterly angle just to pick up on the views and the panoramas, but it also plays a role for heating in the wintertime. We're here in the late afternoon in the fall, and you can see the entire front of the house is shaded, and that's part of the air conditioning system. So that afternoon when the sun is at the peak in the sky, that the trees step in and they become the air conditioner for the house. There's also a 5-foot overhang in the front of the house, and that shades the glazing in the summertime and keeps it nice and cool inside. However, in the wintertime, the sun is much lower in the sky, so that we allow direct beam penetration of daylight into the house, and that's what we call passive solar design. So that in the wintertime, I can be up here and it can be 30 below zero outside, and it can be 30 degrees above zero inside with not even a candle burning. So that's the idea of allowing Mother Nature to do the work for you, placing the building, pointing it the right direction, and once it's pointed that right direction, I call it the gift that keeps giving. You keep getting heat and cool and hydro until you decide that you don't want it anymore.
And I don't know if you can tell, but we are starting to sort of fall into the shade right now, so that natural air conditioning is sort of kicking in right now. Tom, that's really cool.
Thank you very much. You see all my ladders and stuff in the back.
Yeah, that's good though. Well, we're downstairs in the basement now, the nerve center, if you will. And Tom, I gotta say, I was expecting a lot of technology and infrastructure that's used to sort of handle the energy, but it looks like it's really much more simple than that.
Yes, it's very straightforward, and the nice thing about solar power and wind power is all the equipment is totally modular. So that means if you want to add capacity, you can basically plug in another module and you can increase the production. So what you're seeing here on the wall is really the best technology money could buy 15 years ago, so it's been off the grid for that long. But it's all pretty much the same today. Maybe some of the gadgets are even a little bit smaller, but let me walk you through it. So what you see here is the first breaker panel is where the DC power comes in from either the wind turbine or the photovoltaic panels. That goes through this small box right here, which is called a charge controller, and it has a little electronic display on there, and that tells you how much charge is on the battery, how much charge or electricity you're making at that moment, and then it tracks. So since I've reset the meter, I've made some 53,000 amp hours. So there's quite a bit of power that comes through that. So this is all still 24 volt DC power. And that gets channeled directly into a battery bank, which is inside this wooden box.
Oh,
and you'll see a number of batteries all wired into a 24 volt configuration.
So you might have, there's got to be a few hours of excess power here in case anything goes wrong.
Right. When you design these systems, you essentially, if I were to live here full time, I would have designed it for a 7-day off-grid, offline capability. That means I have 7 days of power stored in batteries.
Right here, 7
Right
days.
here. So this is actually sized for 3 days for a full family of 4. So I use this as more of an intermittent property. So again, because of the modular nature, should I want to turn it into a full-time residence, all I would do is add more batteries, and I can even add more panels if I choose. So once everything comes into the batteries, that's where everything gets stored. And once there's any demand, a light gets turned on, or any call for electricity, this box jumps into action, and this is called the inverter. So this inverts DC power and changes it into AC power, and feeds that directly into the house panel. And from here on, from the panel on, this is a traditional wiring, the same you'd have in any house in North America. The solar, and this is also, I should mention, the wind turbine, the incoming power from the wind turbine, again, through a charge controller and into the batteries, and it's there when we need it.
This is and again, it really looks no different from somebody that would be, you know, using the house and flicking lights on. Everything else is the same. It's just it just comes through a different channel here.
This is my power grid right here. So I've never lost power, and I've never gotten a bill. So that's a positive.
Pretty cool stuff. A little too early for a fire yet, but I like the little fire pit you've got here, and I understand this is made from reclaimed materials as well.
Correct. This is just something we saved from the fire pit that a friend decided to make it into a bench. So.
Excellent. I do want to ask about the land here. You know, this is many acres of farmland out here, and it almost looks like it's just being wasted there, a grass field. Why aren't you farming?
It actually is an active working farm. So what you see behind you is a field of clover, and the clover actually fixes nitrogen in the soil. So what that is able to do is take atmospheric nitrogen and make it into a chemical that the plants can use. So as you can see next door, there's a crop of corn this year. And if you come back next year, what you'll see is a flip-flopping of crops, that the crops rotate. That will run generally barley 1 year, we'll run alfalfa for a couple of years to build the nitrogen, and then we can build our plant corn, which takes a lot of nitrogen and grows really nice and big and tall. So it's crop rotation, and you know, you can't be out in the countryside and not gain an appreciation for the art of agriculture.
So just by something simple like that, you're able to prevent the nutrients being stripped from the soil?
It's all trying to mimic what Mother Nature would ordinarily do. You can see on the virgin forest on the land that there's a whole variety of plant species that come and go in a natural ebb and flow. So that's what we want to do, is keep the soil healthy instead of always taking the same nutrients out of the soil.
I got to tell you, this has been a real eye-opener, and this has been fascinating, Tom. Thanks so much for showing us around.
You're welcome, Matt. It's been my pleasure.
Thank you.